Calculus, applications in real life. In this video we'll look at two questions of how calculus can help you solve real-life situation problems. The first question involves a business problem of how to minimize costs. The cost per item in euros to produce X items is C of X is equal to X cubed minus 3X squared minus 9X plus 3. Find the number of items that must be produced to minimize the cost per item. Justify your answer. In this question, we want to minimize the cost of production. From previous calculus problems, we know that to find the minimum, we need to differentiate our problem. We have our equation for the cost of production. C of X equals X cubed minus 3X squared minus 9X plus 30. To find the minimum, we need to find the differential of this equation. When we differentiate C of X, we get C dash of X equals 3X squared minus 6X minus 9. To find the minimum, we need to put our differential equal to 0. So we get 3x squared minus 6x minus 9 is equal to 0. We can solve this using factorization. So we get 3 brackets x minus 3 brackets x plus 1 equals 0. Therefore x equals 3 or x equals minus 1. We can discard the minus 1 because we can't have a negative cost. Therefore, x equals 3. We now need to justify this answer. In order to do so, we need to take the second derivative and prove that the second derivative gives us a minimum at x equals 3. If we differentiate c dash of x, we get c double dash of x is equal to 6x minus 6. We need to prove that this is a minimum when x equals 3. So we find c double dash of 3, which equals 6 times 3 minus 6, which is 12, which is positive. Therefore, at x equals 3, we have a minimum. This means that if we produce 3 items, we will minimize our costs. In the second problem, we want to maximize our area. We have a curve. F of x equals 2 cos half x. Under it, we want to maximize the area of a rectangle ABCD. The line AB joins 2 points on the x-axis. The line CD joins 2 points on the curve 2 cos half x. The height of the rectangle BC goes from a point on the x-axis to a point on the curve. Part A. Write expressions for the length AB and BC. Well, if we make the length 0b x, that means 0a is x. Therefore, AB is equal to 2x. BC goes from y equals 0 to y equals 2 cos half x. So BC is equal to 2 cos half x. Part B, write an expression for the area of the triangle AX in terms of x. Well, the area of a triangle is length times height, which is AB times AC. So A of x is AB times AC. So A of x is equal to 2x times 2 cos half x. So a of x is equal to 4x cos half x. Part C. Find the differential of a of x. If you look at a of x is a product. We'll let u equal 4x and v equal cos half x. Therefore, u dash is equal to 4 and v dash is equal to minus a half sine half x using the chain rule. Therefore, a dash of x is equal to 4x times minus half sine half x plus 4 cos a half x. When tidied up, a dash of x is equal to minus 2x sine half x plus 4 cos half x. Part D. Use your answer from Part C to find the value of x for which the area is a maximum. We know that there is a maximum when a dash of x is equal to 0, and if we use the first derivative test, we know that occurs when the derivative changes from positive to negative. So if we draw the graph of a dash of x and find this point, we know that that is the maximum. If you draw the graph of a dash of x and find the intersection point with the x-axis, you can clearly see there are 2 points of intersection, one at minus 1.72 and one at 1.72. But the one at 1.72, it moves from positive to negative, so that gives the maximum. So the maximum area occurs when x equals 1.72. Having drawn the graph of a of x equals 4x cos half x and found the maximum, you can clearly see that the maximum occurs when x equals 1.72 and its value is 4.49. That means that the largest possible rectangle that can be drawn under the curve of 2 cos half x has an area of 4.49 units squared.